Hey everyone, so today let's talk about what happened in our pressure lab. So, force exerted on an area is basically what pressure is. So, pressure is force divided by area. For a gas, and what we're going to do is related to the number of collisions. So, we're going to look at different changes. So, changes in pressure, volume, temperature, and amount. And we have to ask ourselves with every change, are there more or less collisions happening? So what are these variables? So all the different variables are right here. So we can change pressure. Now pressure is given to us in atmospheres, kPa, kilopascals, pressure per square inch, or millimeters of mercury. Any of those are valid measurements of pressure. For volume, we're going to pretty much stick with liters, but we could also be given it in milliliters as well. For temperature, it's always going to be Kelvin. So it is always going to be Kelvin. We need to have this in Kelvin. And amount. So the amount is just the number of gas particles that we're dealing with. You may see the word mole tossed around, MOLE, but for right now, just know that that means an amount of something. So what does this look like? Let's look at one change. So in this case, we're changing the amount of particles in a container. So we've gone from an amount of 2 to an amount of 6. And our container is flexible, it's a balloon. So we see that the volume of the balloon gets bigger. This is a direct relationship. As I increase amount, volume also increases along with it. So that's all this means. As long as the container is flexible, if I add more things into it, it's going to get bigger. There's going to be more volume. Now, if the container is rigid, as in it doesn't flex, it's not flexible, it's not like a balloon-like material, what's going to happen is the pressure is going to increase. So if I go from an N of 2 to an N of 6 in this container, which is the same size, as badly as my drawing is, they're supposed to be the same size, as I increase the amount, the pressure goes along for the ride. It also increases. This is another direct relationship. As I increase one, the other increases. So what if I make the container smaller and I keep the amount the same? As I change the volume, so from this larger volume to a smaller volume container, but I keep the number of particles the same, is there going to be more or less collisions? In this case, in the bigger container, there's less collisions. There's more space for them to roam. In this one, there's more collisions because they're smaller. They're going to bump off the sides of those walls more. So this, as volume gets bigger, pressure decreases. As volume decreases, pressure gets bigger. In this case, this is an inverse relationship. One, as I raise one, the other drops. Okay. And then lastly, we have temperature. So if you think about it, we talked about temperature as being energy, and temperature is about the speed of those particles. So if I keep the amount the same, so N of 6 and N of 6, the container stays the same, the number of particles stay the same, but I add energy, it's going to increase the speed of these particles. And remember, how did I show that I had more energy? Well, these ones have 4 of these wiggly, whooshy lines on them. This one only has 3 wiggly, whooshy lines. So I'm showing that they have more energy. They're moving a bit faster. So as I increase temperature, pressure is going to increase too. These are going to be faster, so they're going to bump off the sides a little bit more often. And remember, this only works in Kelvin. So to find Kelvin, it's the degree of Celsius that you're given plus 273. That's pretty much what I'm going to give you for any kind of type of conversion there. I probably won't have you go from Kelvin to degrees Celsius. That'll come later this year. But for right now, get comfortable with the idea. If I give you 30 degrees Celsius, it's 30 plus 273 equals the temperature in Kelvin. So it would be 303 degrees Kelvin. But the important part is this is another direct relationship. Increasing temp increases the speed of the particles, increases the amount of times that they're bumping on the inside walls of this container. Therefore, the pressure is going to increase as well. All right, everybody, have a great day.